Okay, my name is Nabil Fikri bin Hashim. Today I will present about the result from calculation method. Okay, first, from the calculation, we obtain the natural frequency for the propene and sorbothane. Okay, for lowest natural frequency for K neoprene 7.11 Hz. For the highest natural frequency, we obtain 17.17. Okay, now we move to K sorbothane. Okay, the lowest natural frequency obtained is 9.36 and the highest natural frequency obtained is 22.468. Now we will move to review on validation method chosen. Okay, for this project, first of all, we need to select one of the two type of validation method that are given, which is the eigenvalue and eigenvector calculator, or we use the MATLAB compiler. So from our meeting, we have decided to use the eigenvalue and eigenvector calculator as our validation method. This is because we choose this method because this is the easiest and fastest way to validate our result. Okay, first we must calculate the value by using manual calculation and obtain the equation. Then we go to the eigenvalue and eigenvector calculator and input the value that we obtain from our equation into the calculator. Okay, from that we can obtain the natural frequency to validate our data. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Anik Kamal bin Abuan Apa, and today I would like to explain about the method that we are using in this project and the validation method. So the method that we are using is a matrix iteration method. So it's related to linear eigenvalue problem, and then it will iterate until it will get a convergence value. A convergent value is a value that after certain iteration it will not change. So we have four separate iteration equation that we are using. For each one of them is for the to find the natural to find the highest natural frequency and lowest natural frequency for both coefficient stiffness coefficient of K neoprene and K sorbothane. Okay, after we get the value, we do the validation method. So the validation method that we're using is, as you can see from here, is a general matrices that use in spring constant in spring mass system. So the first two matrix is the spring mass is the mass matrices, and the last two is the stiffness matrices. So the first one is since we are from group 7, so the mass 1 is equal to 93 and mass 2 is equal to 58 though. So the value of a1 wn square sin wnt plus psi and a2 wnt sin wn square sin wnt plus psi is get from the value of x, where we assume the value of x is equal to a1 sin wnt plus psi. So we differentiate 2 times to get the value. So and then the last two is the matrices of stiffness coefficient. So as you can see, the 950,000 is the value of k1 plus k2, which is K sorbothane plus K neoprene, and then the value of negative 600,000 is the value of sorbothane, and the last one is the value of assuming x is equal to a1 sin wnt plus psi and a2 wnt plus psi. Okay, from there we get the value. After we get the value, in the this is the step to find the matrices that we are using. So as you can see in the lane 3, negative 93 wn square plus 950,000, it will divide by 93 for the first lane, for the first row, and then for the second row it will divide with negative 58, we will divide with 58. This is because to get the coefficient of Wn square that is equal to 1 and make it easier to we put it outside of the matrices to get the final answer of lane 5. Lane 5. Okay, from there, okay, this is after we get the value. After we get the value, we will insert the value, which is we have four value. We will insert at the eigenvalue and eigenvector calculator that we found online, and then from there we will get, it will generate the two real eigenvalue, which is 18450 and 2110.2. So from here, we get the value of lambda 1 and lambda 2. For the lambda 1 is the value of eigenvector, which is the highest natural frequency, and the 2110.2 is the natural is the lowest natural frequency.
Assalamualaikum and hello to everyone. Okay, so I am going to talk about the results and discussion. From the calculation, we have obtained the natural frequencies and the mode shapes of each material. The natural frequency of both materials can be seen in the table as shown. So for the neoprene, the lowest natural frequency that it can achieve is 7.11 Hz, while the highest frequency is the 17.17 Hz. Next, as for Sorbothane, the lowest natural frequency is 9.36 Hz, and the highest frequency it can achieve is 22.468 Hz. Okay, as for the mode shapes of the lowest and the highest natural frequency, first we will go through the neoprene. The first mode shape of the neoprene at its lowest natural frequency is shown in the left side of the screen. It yields both positive values, which is 1 and 0.926. And at its highest natural frequency, the mode shape can be seen on the right side. It has a positive value and a negative value, which is 1 and negative 0.9311. Next, the mode shapes for the Sorbothane. Okay, as for the lowest natural frequency, it can be seen there. It gives out both positive values, which is 1 and 0.948. And the mode shape for the highest natural frequency uh, possess a positive value and a negative value, which is 1 and negative 0.9307. Next, we carried out the validation by using online eigenvalue and eigenvector calculator. From there, we have obtained the natural frequencies and the corresponding mode shapes for each material. From the method that we carried out, the natural frequency at its lowest is 7.311 Hz, and its highest natural frequency is 21.618 Hz. Next, the mode shape of the lowest natural frequency can be seen in the graph is shown in the screen. It consists of both positive values, which is 1 and 0.79602. Next, for the highest natural frequency, it yields a positive value and a negative value, which is 1 and negative 0.78347.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Amir Wahab bin Muhammad Yusof, and I will continue to present about how we select the material that is suitable to be used. So, based on the result that we obtain from the calculation, we decide to select the neoprene as a material that can be used as a coupling spring. And why we select that material is we compare the value of the natural frequency between the value of forcing frequency. So the highest natural frequency of neoprene, we get 17.17 Hz, while for the Sorbothane is 22.47 Hz. So the value of forcing frequency is 22.29 Hz. So we compare and we choose the value that not close to the forcing frequency, because if the natural frequency is close to the forcing frequency, it will cause trouble and problem to the system. So that's why we choose neoprene as our material that suitable to be used. That's all from me. Thank you.